A molecular species is placed in a batch reactor where it decays by a 0th order reaction, meaning the change in concentration with respect to time due to this reaction is equal to minus K, where K is a constant. Given an initial concentration of C0, derive an expression for C of T. Okay, so this is a batch reactor, which means our governing equation looks like the change in contaminant mass given by concentration times the volume of the batch reactor. That change with respect to time is going to be equal to R. Okay, now to find out how to write this net transformation rate, let's think about units. So over here we have contaminant mass per time. That means R has to be in units of mass per time. Now let's think about the units of this constant K. Well, K is going to be, minus K is equal to the change in concentration with respect to time. So if that means K has to be in units of mass per volume per time, right? Because this is a concentration, not a mass. Okay, so in order to change this expression into a net transformation rate in units of mass per time, all we have to do is multiply this by volume. So that's going to be equal to minus K volume, where this is the volume of the batch reactor. All right, now this is an ODE that we know what to do with. Let's assume volume is constant. So then we can write volume times dC. I'm going to multiply both sides by dt, and then I'll get minus kV dt. Okay, so we can see right away that these volumes will cancel, so we don't actually need to know the volume of the batch reactor, we just need to know that it's a constant volume. And now we can go ahead and integrate from our initial concentration C0 to C, and integrate from t equals 0 to t. Okay. So this is a pretty straightforward integration. So dC integrated is just C of t minus C0, and that's going to be equal to minus KT. And therefore, we know that the concentration with respect to time in this batch reactor is just equal to the initial concentration minus the decay rate times however long the contaminant has been in the batch reactor. Not too shabby.